Good afternoon. How did you like James Whittaker's talk? Was it cool? I feel a little bit stupid now. I will not talk about mapping the brain or, I don't know, even sequencing the genome. So I feel a little bit stuck in the 90s. I will talk about a simple problem, understanding what the customer actually wants when we build software. So, well, I'm happy that you all came. And yeah, I want to start with a story when I was from 2009, when I was at PDC. That was when we did for about the second year Scrum, so we tried to do it and to follow the principles. And we were feeling the pain of regression testing, manual regression testing at that time. And we looked around and we found a tool called Cucumber. Unfortunately, we were working on .NET. I don't know if you have tried already to make .NET developers working with a Ruby tool. You hear all kinds of cursing and swearing.
That's just normal .NET.
Yeah. So that's why we started. Okay, after I think 3 sprints, our team said, okay, we build our own tool. So we'll do the same thing. The concept is cool, but it just doesn't work out for us on .NET. And that's when we built SpecFlow. And back to BDC, it was actually shortly after we have published SpecFlow on GitHub. And I went to the patterns and practices team of Microsoft. I was very excited. Yeah, look what we did. And they were quickly referring me to somebody in the patterns and practices team who knows that stuff, who knew it longer than I even know that it existed. And he looked at me and said, yeah, that's cool what you're doing. Then he had a sad look and said, yeah, but you know, the .NET community is probably not the right community to use that. Nobody will be interested in your tool. It's already so long around. They will not pick it up. And I was like, shit. Wrong platform? We like .NET. So we do all our projects in .NET, mainly. We started to do some Java recently, but basically at that time we were doing only .NET projects. So 4 years later, actually this should work. My clicker, I didn't test it. What's with my clicker? Okay, that's the only thing I didn't try. I used the mouse. Okay, 4 years later. SpecFlow is a lively project. And I don't know if the guy was wrong or if things just have changed. 4 years later, I'm standing here, and I was invited to give a talk about SpecFlow, or actually about the method behind SpecFlow. Because my goal for this talk is not to push SpecFlow as a tool, but rather to introduce you to the method behind SpecFlow. And I think this is a method everyone should know who's doing software development. So who hasn't heard about specification by example, acceptance test-driven development, BDD so far? Okay, who has just heard about it because he read it in the abstract? Who didn't do anything with it yet? Okay, so that's my first goal. Those guys here who have heard about it probably, but didn't use it yet, to make you so curious about that in this session that after that session you go home and try it out. The other part of the people who is using acceptance test-driven development already? SpecFlow or something else? Okay. So for those who know SpecFlow already, I want to give you some new perspectives on using it. So I don't know how you're using it. There is a birds of a feather session after this talk, which I would like to meet all of you who are doing this already and hear about how you're using it. But my goal for you is to not only see the tool, but the method behind it. All right. Just a quick info about my context, as you hear from my nice accent and from me putting the words in the wrong order in the sentence sometimes. I hope it doesn't cause too much problems understanding me. I'm from Austria, in Vienna. I regularly travel to Zurich and to Budapest, where we also have teams. We do software development and consulting. So everything we are consulting, we're also trying out alone, about 50 people. So just that you know in what kind of context I live in work. All right. I will say specification by example throughout the talk, because that's the term I use. However, you have heard probably other terms for the same thing, and I don't want to disregard these or make them smaller or less important. But I was giving a talk quite recently at a conference, and suddenly in the middle of the talk somebody said, you're talking about BDD. And I was like, yeah. I mean, that's also another way to say it. So I put it now as a disclaimer. Don't be confused. I use the term specification by example. And I can tell you why later, probably. Good. When we started using that, we were actually not looking for yet another method to work with requirements in agile projects. We were rather thinking about easing our pain in regression testing. However, this is a specification method, and this is one of the goals of my talk to make you understand about this. So I guess all of you know user stories, right? Everyone is working with user stories. Don't worry, I will not explain what a user story is. So, however, I think it's quite interesting to understand what the purpose of a user story is. User story has many purposes, depending on for what you're using it. And the particular purpose I'm interested in this talk of a user story is that it's a mechanism to defer detail. So something you can write up, and you know you don't have to go deeper into it at the moment. And at some point, you want to write some code. And there's quite a gap between a user story and the code, isn't it? Some developers said the actual requirements are only in the code, so the documentation, what actually happened. So if I want to know what the system really wants to do, I have to look at the code. User stories are pretty bad in describing in detail what a system does, right? So why do we write user stories? Why don't we just write the code? Okay, first of all, most of the customers don't know how to write code. And it's hard to define upfront what you actually want. So you need some abstractions and some less concrete ways of telling what you actually want to do when you are talking about what the system should do. And Alistair Cockburn came up with this idea of the levels of requirements, which are, so he said, he wrote a book about use cases many years ago, which still has a lot of things in there which are interesting. And he said, the level of a requirement is determined how much it answers the question why you want to have something, or how much it answers the questions how you want to have something done. And the user story is pretty much somewhere floating on the, he calls it the user goal level. So it explains roughly what the user wants, but it doesn't explain it very detailed. And of course, in agile requirements, there is a lot of things above a user story, how you can model higher level requirement goals. I will not go into these, but if you're interested in that, I suggest that you look into methods like impact mapping or story mapping, which deal a lot with how you model higher level requirements in a project. What I want to discuss in this talk is about what happens in the gap between writing a user story and writing the code. What do you need to do there? And you know, everyone knows probably the term user story is a reminder for a discussion. So there is a discussion happening. But what happens after the discussion? So what do you do? I think everyone is using user stories. After discussion, do you write something down after the discussion? Document? Acceptance criteria, tests, exactly. So some of you are using that already. What's another way of specifying a little bit more in detail what a user story should do? Okay, what is the result of a test? Sometimes.
Validation.
Yeah, and if the validation fails?
Got work. Not done.
A bug report, or somebody writes down what didn't happen the way he wants. So I've seen entire systems re-specified in bug tracker. And I think that's the most horrible thing that can happen. So bug reports are also sometimes a way how users tell us or stakeholders tell us how they actually wanted the system to behave. They are often written, so proper written bug reports are isolated formalized examples telling in this specific aspect I do these steps and I expect this outcome, but another outcome comes. The only problem with the bug report is it doesn't happen shortly before you implement it, but shortly or long after you have implemented the system. And that's the problem of a bug report. And the idea of specification by example is actually to use examples to better illustrate your acceptance criteria and to avoid these bug reports and make them shortly before you write the code and not after you wrote the code. You will not get bug-free, of course, but you will have many bugs then. And that's the idea of specification by example. All right, so let's first look on how we collect acceptance criteria. So there's many ways how people do it. I just want to introduce how we usually do it. I usually look at the user story and try to basically sit together with the stakeholders and ask them, imagine the story is done already. Imagine this story is not to be done in the next sprint. We just did it. What would you try out? So what would you try out if you would want a shopping cart? What would be the first thing you would try out probably?
Put a book in the cart. See that I've got one.
What was that?
See that I have a shopping cart.
Yes. Put a book in the cart. See that you have a shopping cart. What you would see, whether you see it, right? Yeah. OK. Right. So putting a book into the cart would probably be the first thing. And trying to remove a book would be probably something I would try. But there are also other things you would try. Probably, if you are a more technical person, you would check whether the shopping cart is empty when you enter the shop, that there is no side effect between sessions. User would probably not think about it first. I was using an online shop in Europe, which is quite popular, and you can buy clothes there, and I'm too lazy to register for the shop, so I'm buying with the account of my wife. And we sit together in the evening, both on the couch, and she's doing something on her computer, and I do something on my computer. And suddenly I see how the shopping cart in my browser starts to fill with stuff from her. So I was quite surprised about that behavior. Still, this seems to be an intended business rule which the shop implements. Another thing I would try probably is to add the same book to the shopping cart. And that is already a question where I don't know what should happen, for example. I mean, we assume it now. I guess everyone assumes that it will count up the number of items of this book. But it could be also a warning, or at least a friendly disclaimer that you have put the same item twice into the cart. What would a tester ask, probably, with a shopping cart? Who is tester? OK. So what's an extreme case you would try out, probably, as a tester?
How many books can you fit in the shop?
Yeah, exactly. I would put 1,000 books into the shopping cart. And everyone who is a developer would probably laugh. Who would do that? But now the question is, which number of books should the shopping cart still accept, and which numbers don't you want to accept anymore? And that's a business decision. So looking at extreme cases is a very important aspect when you are discussing acceptance criteria. And I will come later to this. That's why it's so important to have all the different points of view on the table when you discuss this. All right. So this was quite abstract yet. So we said what we would try out, and we wrote down some abstract acceptance criteria. Who is doing it similarly so far? Who is writing acceptance criteria similar to that? All right, good. So where do we have the examples now? So the talk is called specification by example. So actually, we are using examples for user stories already. We often use some kind of examples how the UI might look like. Either some screenshots of the existing system which we want to change or extend, or some UI wireframes or anything else which gives me an example how the UI might look like. Users often come up with existing artifacts, the famous Excel sheet that will be replaced by the system, for example, or some mock-ups they did, some report, how they imagine how it will look like. These are examples that we are using already. Or if we have complex business rules, we probably start to model some example cases to understand how the business rules are working. It's very seldom happening that the user comes with a formula and telling me, this is the formula you have to implement. Probably if you are in a special domain where you have physicists or mathematicians, then they will come up with a formula. But then I will probably have the problem that half of the team will not understand the formula in the first case. So we try to understand and build up a shared understanding with examples anyway already. So how does this discussion go? And this is an illustration I got from George Dinwiddie, because I think it's so genius, I have included it into my slides. So how does this discussion work? So business tells an example what they want, or it tells what they want actually. And then development makes up an example how they understand what business wants, right? And of course, probably testers also start to think about how such an example might look like. The problem is that these examples are not shared with each other, and probably business doesn't even understand or can read these examples. So although we use these examples in the discussion, we are not sharing and understanding each other. And I guess most of you have seen that already, that we are building a system and different people in the team are creating some small things, how they can try out while they develop the system, how to try out what they're actually developing. Even business usually has their secret Excel sheet or whatever, which they will try out when we finally let them play with the system. And suddenly you're surprised, oh, I didn't know that you're going to try out this thing or this case. All right? So Brian Mary coined the phrase, an example would be right handy about now. So he wrote about this already many years ago, before there were, so I think after that Fit and Fitness came up as one of the first tools trying to support this kind of methodology. And I have a son who is 8 years old, and he asks a lot of questions. And when I'm not in the mood of answering a lot of questions, I'm trying to give him the most abstract answer I can give to his question. And then if my wife hears that, she says, Christian, he's 8 years old. You cannot give this answer to him. So what I have to do then is I have to give him an example and explaining what he was actually asking about. And what will happen then? He will ask more questions. And more questions and more questions. And actually, while this is nice if I have time and I can play or talk with my son, this is also good in software development. You don't want to receive a specification that is abstract, and you don't want to have any further questions. You don't want to have no further questions. You want to have actually people who get this specification understanding what this is about and ask further questions. And that's the idea of specification by example, to use these examples to make abstract descriptions better understandable. The only point and problem is that we usually don't take the time to share and formalize these examples or document them. We just use them in our discussions, and we are not taking the extra time to further use them when we build the system. And that's the idea of specification by example. We use examples to describe what we want to build, and actually tests who can verify these requirements are consisting of these examples. And if you're formalizing the examples, the tests, and the requirements, you will ultimately not be able to distinguish between these three things. So tests will become examples, or examples will become tests, and examples will also become requirements, specifications for details. So going further with this, instead of having isolated views on the same thing, we are trying to have a discussion around the example which everyone understands and take the time to document this. And what will happen then is new questions will come, new aspects will be discovered. So what I often see is that people are using tools supporting this, and they are actually writing these specifications and handing them over instead of having the discussion. That's the wrong order. You should first have the discussion, have the questions, discuss these, and then document what was the result of your discussion. This collaboration is also often called the Three Amigos. There were other names for that as well, which were not to be used in public. So very funny. Three people doing something together. There's a word for this in English. So they called it Three Amigos finally. Three Amigos doesn't mean that this discussion has to be done by three people, but it means that every hat, every perspective should be present in this discussion. And usually you have somebody who is thinking in the happy path. Usually these are the people who want to have some functionality. They don't think about what probably a developer will think about, like technical things you have to consider when building the system. What is possible, what is not possible. And very important, testers are usually very good in thinking in exceptions, border cases, extreme things, which have to be decided as well. If you don't talk about these before you start building the system, you will end up with bugs. You will end up with discussions whether this is now a bug or a feature. And having these discussions up front helps you avoiding this. And you can even scope things out in this discussion. Say, OK, that's a valid exception, but we will not handle this in this sprint. So how do we document this discussion afterwards? So let's have a look at our example user story with the acceptance criteria we had. Let's take the first one, and let's say how would you try out, or what would you try out when you are trying to add a book to the shopping basket? I would book an arbitrary. I would first of all want to see what state is the shopping basket in, like it's empty. And then I would pick an arbitrary book, like let's say Harry Potter, and add it to my shopping basket. And afterwards, I would check whether this book is actually in the shopping basket. I know that's a very simple, stupid example, but for the sake of this presentation, I'm not able to discuss or give an intro into a more complex domain in such a short notice. Again, if somebody's interested in how this looks in a more complicated scenario, I'm happy to discuss it afterwards. Let's have a look at the second example. That's a little bit more complex already. So what does it mean you can add it multiple times? You add it. You have a shopping basket where there's already a certain book. You add the same book again. And then you check you have 2 copies of it. OK, also very simple. These examples follow a certain structure, which is, in my opinion, quite important to understand and keep. You have the title of the scenario, which is often forgotten when people are writing these scenarios. The title is describing the abstract acceptance criteria, the intent which you want to illustrate with this example. It gives you an intro what you will expect in this example. This is a very simple one, so you don't need it actually. But if you have a more complex example, which is probably longer, not so easy to oversee, then this title is very important to prepare the reader what to expect here. The first part of the example is always describing the initial state or the context of the system. What has to be given in order to observe the behavior we want to describe as this example? The second part is the actual execution of the system. So this feature, how it is utilized. And the third part are the observable behaviors, assertions you want to do on the system in order to be sure that the system behaves in the way you want it. Testers know this kind of structure, right? How do you call that as a tester? Checks? I don't know. Anyone knows checks or AAA constraint? So that's the same, actually. And you can chain up steps as well. So like, you can have an additional warning, for example. So that's the structure of these examples. And what will happen is, if you have these discussions in the way I outlined here, and you document these discussions in that way, you will gradually evolve a domain-specific testing and specification language about your system. So now we have discussed, we have written down what we actually want to build. Everyone knows what we want to see in the next sprint. So we have a shared understanding about the acceptance criteria. That's, I would say, the first goal which we want to reach with this method. And even if you don't want to use anything else I will show you afterwards, this is, I think, the main takeaway you should take from this talk. How you make better understandable what you want to build in detail in a system. But if you write this down, these acceptance criteria, these examples, what will happen after some time? You will gather a lot of scenarios, and it will be very hard to oversee them after some time. So I don't know, anyone had the problem already? All the acceptance criteria after 10 sprints, you want to see what was violated, what you discussed in the first sprint? No? For us, this is often a problem. So we have, if we had this in the beginning, we wrote down what we built, but there was sometimes when somebody was coming back and say, this is something we developed 2 months ago. I want to change something there. Why isn't it behaving like that? And I know we discussed that, but I didn't know anymore what was the decision, why we did the decision. And having a documentation that is reliable and telling me what the system actually does in that part would be very useful in that case. If this would be just written, well, so written down examples which would have been somewhere maybe on a SharePoint site or I don't know where nobody looks at it anymore, then it would be very unreliable to look into this. I would rather look into the code or talk with a developer to look into the code or with a tester and see what they can make out. And yeah, they can do that. I mean, we can talk. But it would be good to have a documentation if we took already the time to discuss and document these examples. Another thing which would be interesting is that after each sprint that I get some kind of security that everything we have discussed already is still valid. So every example we looked at, every case we discussed is still kept. And if it's not kept, if there is an error, I would like to have a good description what is not working anymore. So the solution to these two further aspects, documentation and regression testing, which tell me what is going wrong, is automation. And that's yet another thing you can do with this. And this is where the tools come into the play. So if we have these examples described like this, there are tools where you can basically bind or automate each step to an automatable interface of the application. So you write small automation code that automates each of these aspects. And this doesn't have to be necessarily through the UI. So you can have it, you can do it through the UI, but you can do it also through lower level interfaces. And the good thing on this is that you build the automation together with the system. So anyone tried already to write automated tests for a system which has been done already, so where you try to do it afterwards? The most painful thing you can do. So writing the automation together with the system is, in my opinion, the only way how you can do automated regression testing. So that's the idea of continuous validation. And who has seen SpecFlow already? I think it was about, well, a quarter, maybe. So for all the others, I want to show you how this looks in Visual Studio. And again, this is not the only tool you can do this with. So this is just a tool I'm working with since many years, and that's why I'm feeling comfortable showing it with that tool. So SpecFlow is consisting of a Visual Studio plugin and a NuGet package. The Visual Studio plugin is basically introducing a project type and some editor features to edit the feature files which are describing these scenarios. The NuGet package is something which you're connecting to your project, which is basically then the testing project, some API, which the automation uses. So I have a simple bookshop sample application here. So this is a simple bookshop. I can search. I can look into some search results. I can add something to a cart. I can remove it again. And you see that I have here the web application. And here I have a separate project which is containing the acceptance tests that are describing the functionality, the detailed specification of this application. So the specifications I have here are versioned together with the source code of my project. That's, I think, an interesting aspect. And each specification can be written in a so-called feature file. And a feature file basically has some header, and then you have individual scenarios described in the feature file. These are mainly the acceptance criteria we had before. And for each acceptance criteria, we have then the examples, as you have seen it before when I described how you build these examples. And in this case, we have extracted some setup into this background. So you see here, basically the given is executed for each scenario. I will not go too much into detail of the syntax because I think that's boring to explain too much about this, but just that you understand this. So given the following books, when I search for a book, then the list of found books should contain this book. So how does this become now an automated test? Behind each of these step definitions, and this is something which you can do with the Visual Studio integration that comes with SpecFlow, there is a small piece of automation. This is how you can wire up the automation to these scenarios. And basically, the matching works either with a regex, which is put up as an attribute to the step definition, or there were some people complaining about that this violates the tribe principle, and they don't know how to name the methods, or they have to copy that. We can also derive it now from the method name. So it's not so elegant as you could do it in Ruby, where it looks like almost the sentence you would write. But I think it's good enough to basically match the step definition to the method name that does the automation. And you have seen before we have a parameter here, so like the search phrase. And this is handed in as a parameter to this automation method. Okay. What happens then is that SpecFlow will generate out of these feature files and these small automation snippets a unit test or a set of unit tests. We support different kinds of test runners, so it can be done for NUnit, for XUnit, for MS test, and so on. And then we can execute these unit tests as basically executable specifications. So just to give you an idea how this works, you see here all the tests which are green. Let's see. And OK, that's not too exciting. I will now break a test, like I search for domain X. I will not find anything anymore then. So if I execute these tests again, you will see this title should be match test will fail. And I can see now in the output what actually failed. So I can see that this was actually the scenario which was executed, and this is the assertion that failed. And I think this has some value, because if you have test automation, you don't know what failed. I don't know. It happened often that we had automated tests where we were just busy fixing the tests, but it was not giving us any value of fixing the tests, just having the build green again. But we didn't know what actually happened. With this kind of output, we actually know what was violated. And usually a failing test is valuable information for us, and not only just the problem that we have to fix the tests again. You can also debug here. So we can set breakpoints here and debug the tests. So I can step through scenarios, which can be helpful sometimes, and I can step into the automation. So basically, that's how, again, this is the assert that failed now because I broke the test. So basically, this is how an implementation of this method can look in a tool. Another thing which I want to show you is that I mentioned before that you don't necessarily have to automate through the UI. So these tests are going directly through the controller. If you looked here, this is an MVC application. So we were just instantiating the controller and running the test directly on the controller. But you can also run it through any web automation. Like in this case, if I set this attribute on the feature file, we have some bindings which are bound to this special attribute. And now the tests will run through the browser. Let's check. With Selenium. So you can use it with any kind of UI automation technology or whatever you want. And notice that the phrasing, I broke the test. Now it will search for the result, and it will take some time. Let's abort it. And what is interesting here is, the point I want to make is that I didn't change the phrasing of the scenario. So the scenario didn't tell me whether I automate through the UI or through a controller. The scenario still captures the business intent of the test and not technical details of how I automate the test. Let's run it again. Now you can see it. All right. Okay, so that everyone sees it. Automated process. So these are all the scenarios we have here running through the browser. Good. So this was just quick demo of how this method can be supported by the tool. I want to look now also on how this will impact other things you do in a project, like testing and development. So let's first have a look on what will happen with testing if you do this. And I told already in the beginning that when we started to use this, we were not looking for a specification technique, but we were rather looking for a way how we can ease our pain in test automation. And we failed before several times in introducing test automation by using Selenium directly, for example. And when we tried again, and finally succeeded, we looked back and tried to find out what did we do differently. So why did it work now? And we found 3 things which we think were important, what this changed in how we do test automation, and why we finally were able to do that. And the first thing was that we tried to, in the first attempts where we failed, we tried to automate tests which we do, how we do them manually. So we didn't think about how we structure our tests. The second thing is that when we used Selenium directly, tests became unreadable. And the third thing is that we often had an automation team which tried to automate after the developers. And these were, in my opinion, the three things why we were not initially able to automate our tests. So let's have a look at these three aspects and how they are changing if you follow this methodology. Structure. When we do manual tests, we usually test several features in combination, right? So like if I would test the web shop, I would probably do some searches, put things into the cart, remove something from the cart, try to check out and see if it finally works, right? So I have a structure which looks like act, assert, act, assert, act, assert. And the previous act asserts are always the range for the coming act asserts. The problem with this structure for automation is that I can only automate this if I have all these features together. That's the first problem. And I have quite a long test path which goes through many features of my system, which means that if any of these features changes, my test will break. And probably the cause and the impact of this change will be quite far from each other. So I change something here, and 5 steps later, my test breaks. So it will be hard to understand in an automated system why this test failed. It's not a problem for manual testing, because as a manual tester, I probably understand what I'm doing. But if I have hundreds of automated tests and suddenly a test pops up and fails, I'm not in the context of this test anymore. I've forgotten about it already. So fixing the test is much harder than if I do this manually. However, there is a reason why we structure manual tests like that, because the bottleneck of executing manual tests is the manual clicking. If we would structure them in individual tests, we would never ever finish manual testing. So we were optimizing basically for something which we didn't need anymore, because we wanted to automate the test. So execution was not our primary bottleneck anymore. If you look at these automated checks, as you have seen them in the specification, these are isolated single aspect tests on a single feature or a single aspect, a single acceptance criteria of a feature or a user story. You can build them without having the other features in place, and the chance that this kind of test breaks is much lower than if you have an automated test that goes through the whole system. And if it breaks, you will see much easier the cause and the impact of why it broke, which is important if you have hundreds of tests which you want to maintain, which suddenly pop up and go red. And probably everyone has seen the test automation pyramid from Mike Cohn. Everyone? No? Yes? So this is actually just saying that. He's labeling it a little bit differently. He's calling the top here the GUI tests. Then this he calls the service test, and this he calls the unit test. So he has distinguished between the structure of tests. So the tests which do a lot of act and assert are basically on top of the pyramid. The acceptance criteria tests, or what he calls service tests, are isolated tests on a single aspect. And there is one more granular set of tests, which are the unit tests, which are testing basically a single unit, a single responsibility of a unit in the ideal case. So why is this a pyramid? Because what Mike Cohn said already, and if we would have read this before, we would have come probably earlier to this conclusion. The more you are doing tests like on the top of this pyramid, the harder they are to automate. The more you do tests like on the bottom of the pyramid, the easier they are to automate. And this is for 2 reasons, the 2 reasons I mentioned already. The first is a technical reason. It's easier to automate a unit test than to automate through the UI, isn't it? That's an obvious one. The other one is the length of the test path. So a unit test has a very short test path. A journey through the system, which chains up many features, has a much longer test path, which makes it much more likely that your test will break after some time and that you will have to deal with maintaining it. And why this is a pyramid is that Mike said, if you have many of these unit tests, you get away with having few of these higher level tests. And since these are less, you probably don't even need to deal with automating these higher level tests. You can still try, but it's not probably your most concern. And that leaves more time for what is called exploratory testing. Tests you cannot automate by definition because this is testing and learning about the system at the same time. The second part was the readability. I think it's clear to everybody already. So this is how a recorded test looks like when you are trying to automate directly with a UI automation tool. This is what we tried first. And this is the same test written in Gherkin. So if this test breaks, it's much harder to find out what broke now. If this test breaks, it's much easier to understand what broke. And I can do something about it. And the third point was when we did the test automation. So we had initially a team, even when we started to use SpecFlow, which was doing the automation. So people in the team who were specialized on that. And that was horrible. Because the developers didn't care at all about making the system automatable. So they were always, the team who had to automate was always lagging behind, and there was just friction. And there is a quite good model to show what we are actually doing, because if you look at traditional testing, when you do manual testing, you often do either exploratory or workflow tests, and also some kind of technical tests like performance, scalability, usability. And these types of tests have in common that you can only do them when the system is done already. So this is what was our default way of thinking about testing. You can test only when you are done with the system already. That was the big mistake. And developers already found out earlier that there's another type of tests, which they called unit tests. Some even regret that they called it unit tests and not unit definitions or something else, which is used in test-driven development, which are actually written before you build the system and not after you build the system. And acceptance test-driven development is just the business view of these unit tests, which are business-readable unit tests on a high abstraction level like acceptance criteria. And this view on testing was also described by Brian Merrick initially, and he called it the agile testing quadrants. What I also see sometimes, if people are starting to use SpecFlow, that they have managers who tell them, OK, you don't need manual testing anymore. We automate everything. We don't need manual testing. And that's yet another problem which can come. So of course, you have to check each acceptance criteria manually once, at least. But having the automation will mean that you have to do much less manual regression checks. Probably not no at all, but much fewer. Of course, you still have to test the main success paths to the system. But building on this pyramid means you can get away with much fewer paths through the system, which you have to either test manually, or if you want, you can also try to automate them. It's just much harder than automating acceptance tests. And you will always have undiscovered acceptance criteria, no matter how hard you think about what you would try out when you build this user story. But building on all this means you have more time for this kind of testing, which I think is the most valuable testing in nowadays project. Finding out things you don't even know that you don't know them yet. And this has an impact on cross-functional work. I'm often asked, how can we prevent that testers have a second sprint after we developed? And actually, testers, after that, it should be quite clear how this works. Testers are collaborating in defining the acceptance criteria. They can even over-specify the system based on this kind of example. So like we discussed a few examples for the shopping cart. Probably the tester wants to write some further examples, which he has now a specification language which can be automated, which is automated already, where he can test additional cases which are not needed anymore for understanding, but for being sure that certain aspects of the system are really working as intended. And I often see that in the automation itself, testers can also participate. So developers usually build, so that the whole automation layer is a first-class citizen of your system. It has to be refactored. It has to have it has to be well abstracted. And usually testers can get into this. So they can write step definitions based on this abstraction layer, sometimes even alone, if they are technical. Another thing which is important is that, of course, you don't start all user stories at the beginning and end all at the end, but you try to finish one user story first before you go to the next. It's not often possible that the whole team swarms on one user story, but you can limit the work in progress within the sprint. And you can start earlier with manual exploratory testing then. What this also means for the teams I work with, at the end of the sprint, of course, everyone is testing. Because before developers are starting a new story, and which is anyway not tested anymore in the sprint, I rather have everyone on the team finishing the things that were in work, and testing is part of finishing the story. So at the end, everyone will test. And this allows me to have short iterations where I can actually finish tested stories at the end of each sprint. And what the tester will actually do is not only testing, but he will collaborate in the specification. And I think the main goal of the tester is not anymore to find bugs, but to prevent them. Finally, how does this look for development? I think everyone knows this TDD workflow. And acceptance test-driven development is just extending this to the acceptance test level. So I write a failing end-to-end test, which is a scenario. Then I start implementing the scenario, probably using TDD. And then I have, in the end, a passing scenario. And then I go to the next scenario. So how does that look like? This is a dashboard of a project of us where we always post what is in progress in the current sprint. And there is something which is called the current sprint report, which looks like this. This is a report generated by SpecFlow. And what you can see here are the user stories in this sprint which are planned. And you see here the scenarios we have defined for each user story. So we have 8 scenarios for this user story, 30 for this, 5 for this, and so on. Purple means that there is no automation for these scenarios yet. And this is the first sprint in the project. So you see here the builds counting up, build number 7. And when the sprint starts, we take the first scenario, and the team starts to automate the scenario, and it will fail initially. And then they extend the system or build up the system so that the first scenario passes. And what you see here is, while the builds are counting up, you see how more and more scenarios are passing in the current sprint. And you see now that the story is ready for testing already. But you can also see stories where not all scenarios are passing yet. You see what is not working yet and what is already working. So you can probably even look at a story which is currently in progress and start using it in your manual tests, even though it's not fully finished yet, because you see what is working and what is not working. I think this is a big difference of over looking to a task board and seeing which tasks are not finished. Having a task board is very good for the team to organize their work, to parallelize their work, to coordinate. But for somebody who wants to know what is working already or not, having a view on which acceptance criteria are working already and which are not is, I think, much better to tell what is the current progress in the sprint. Also, if something breaks, you have a quite quick view on, or you see quite quickly what's actually not working yet anymore. And you can probably work around in your testing, because we want to test during the sprint, not after the sprint. All right. I will make the living documentation very short, because I'm running out of time. So if somebody is interested in that, afterwards at the Birds of a Feather session, I can show you how you can link Gherkin scenarios with story maps. Who has heard about story maps? Okay, what we are doing is, and that's what I want to briefly just mention, that we work with story maps to visualize the product backlog and to basically drive the product design. And we are linking the Gherkin scenarios to the maps. So you can see in a map and drill down from a higher level view that the map gives you to the scenarios. All right. I will skip this point. Some lessons learned for us. First thing is, don't use this to replace your collaboration or to make your collaboration not happening anymore. I've seen too many teams who dig into this technology and suddenly somebody writes scenarios and hands it over to the team, and they don't speak with each other anymore. This will not work. You should actually use this technique to trigger new questions, to have even more discussions than you had before, and only after that use it to document what was the result. Another thing you will notice that at some point, since these are not unit tests, you will have to deal with performance. So while we said it's much faster than manual testing, these are much slower tests than unit tests. And there's different techniques you can look into how to make these acceptance tests faster. The tools I mentioned, I said that the main goal of this talk is not to talk about the tools. Still, I have some preference what I use, mainly because I like to use Gherkin because I know this is possible on several platforms, and there is a whole ecosystem of tools which are working together based on this Gherkin description language. So you cannot only use this on SpecFlow, you can also use it on other platforms. I have this flyer here if you're interested in this, how the collaboration works, and also in this story mapping with specification by example combination. You can have it here. Some books I recommend. I think the main book you should read if you are looking into this is Specification by Example by Gojko Acic. The reason for that is it doesn't describe you it's not a step-by-step guide how to do it. But what Gojko did is he was interviewing several teams who were using this technique for several years, finding patterns, what worked well and what didn't work so well. And he also described some case studies of what was the impact on teams who were using that for several years. So if you want to convince somebody from management who probably says, are we the first who are doing this, or does this actually work? I think this book is very good. And if you actually want to do this and want to see what kind of pitfalls you want to avoid, this book is also very helpful. Bridging the Communication Gap is a little bit older book, which is describing the main problem. This is more like giving you a detailed view on how to work. And I have two books here which I want to recommend because using this technique changes the way how you test. And I see that there are many teams who don't know how exploratory testing works. And I think this is very important to know how it works. Especially if you use this technique, you have time for it finally, and to do it properly. So these are the two books I can recommend to anyone who wants to look into this, from Elizabeth Hendrickson, the book, and from James Whittaker. All right, summary. What I wanted to convey with this talk was, first of all, that this is not about a tool, but about collaboration and discovering things you otherwise would miss if you would write specifications. Using this technique will have an impact on how you develop and test. And you should use it in combination with other specification or requirements management techniques. So don't use just this, but also think about the higher level requirement goals, which I mentioned. And it will not replace any methods you use on a higher level. And while the tools are not the most important thing in this kind of technique, there are a lot of tools out there which support it. So if you think this works for you, then you can look also what kind of tools there are. All right. It's 3. I don't know if I have time for questions, if I'm getting thrown out here. There is this Birds of Feathers session coming up right after this talk. So if somebody wants to have a deeper discussion, please join me. And yeah, thank you for coming.